Second example from stationary points, we're going to have to firstly identify the vertical asymptotes of our graph. So for a vertical asymptote to exist, we're going to let the denominator of x squared take 2 be equal to 0. From our factorization, that's going to give us two solutions. Multiply that to give us -2, but add up to -1. So x take 2, x plus 1. So using the null factor law, our results will be x equals -1 and x equals 2. So vertical asymptotes will be needed later when we're looking at a sign diagram to include in our second part, part B. When we are identifying part B, we need to use calculus. So there is a fraction both containing x, so we're going to have to introduce the quotient rule. U being equal to 3x take 9 gives a derivative of 3. V being equal to x squared take x take 2. V dash being 2x take 1. And we need v squared for this, which is x squared take x take 2 all squared. So our derivative with respect to x is the derivative of u times by v, take u times by the derivative of v, all divided by v squared, So to identify the stationary points, we're going to equate that to 0, and it is only the numerator that is going to be of value to us. So we can expand that out. Negative and a negative makes a positive. -9 times -2x gives us plus 18x. Negative, negative, and a negative is going to be negative. So grouping like terms, we have minus 3x squared plus 18x take 15. All of those numbers divisible by 3 means we can take out a common factor. So we're looking for numbers that multiply to give 5, but add up to -6. And again, from our null factor law, that will result in two stationary points, one at x equals +1, one at x equals +5. So from that information, we can then draw our sign diagram. Remembering on a sign diagram, we need both x-intercepts, but also our vertical asymptotes from part A. So we'll label those in. So we want to identify the signs of all of those. To help us with that, we've got our technology. So to the left of our asymptote, we have a negative slope. In between the asymptote and our what appears to be a minimum, we have a negative slope into a positive slope. We're then going to identify after the second asymptote of 2 that the slope is again positive, and then there will be a maximum here if we've done it correctly to result in a negative slope. So we can check that. I've already got the local minimum at 1, 3, which would be this section of our sign diagram. And if we've done it correctly, we should be able to find the maximum at 5, and that would be 1/3. So the key thing here is to remember to include both your vertical asymptotes and your x-intercepts along your sign diagram.